Hey, what's going on, CMIS102? We'll go ahead and get started this first week of information. So hopefully you've read the assigned reading before you watch this lecture. It's pretty important that you do that. So if you haven't done that, go ahead and grab your text and read through that. I've got the assigned reading in the discussion. So this week we're going to be talking about a few things that's basically laying the groundwork for the remainder of the course. Of course, we're going to start with an introduction to computing and an introduction to programming. The text, chapter 0, begins with the importance of understanding the history of computing, and this is pretty important because we move from just very basic concepts up to the technology that we have today, which year by year it's just fascinating how quickly the technology advances. And of course, the ideas of networking and leading on into the internet has certainly advanced the technology and the capabilities in technology greatly, as well as providing just access to a vast breadth of information on everything. The text identifies the computer components that we're going to be talking about in this course as the CPU, or the central processing unit, internal memory, which is ROM or RAM, mass storage, which of course is a magnetic disk, a hard drive, or optical disks such as CDs or DVDs, and solid state devices such as a thumb drive. Now, there are also solid state hard drives, which are just phenomenal. I've actually recently upgraded my machine with a solid state hard drive, and it's wonderful. It boots very quickly. Input devices and output devices. Of course, we have the standard devices that we're mostly familiar with, that we use most often. Keyboards and mice, of course, are the standard input devices, and the monitor, which is what displays visually what the output of our programs, or the web browsers, or whatever you're using. And of course, a printer is a common output device. The text talks about different types of software, such as application software and system software. System software, of course, is contained in your operating system and interacts with the hardware within your computer, and provides you with a graphical interface that's easy on the human eyes. And the application software rides on top of that. It's software that you can interact with to create different files. For instance, of course, the Microsoft Office suite is a very common application software. The text also talks about different types of programming languages. Machine language, of course, is ones and zeros. That's what the computer understands. And of course, if we were to see that language, it'd be very difficult for the human eyes to understand what's going on. And then one step above that is assembly. Assembly language is it's still a programming language, but it's a one-for-one programming language, which means that for every assembly command, it does one thing in the machine. If you've ever taken assembly, you certainly understand the how it can translate very easily to machine language, or to machine code. And then the step above that is high-level language, such as C++ or Java, and of course, you can use different commands to accomplish different tasks as you put those in varying methods in your code. Programming, of course, is to develop a series of commands in your program that instructs the computer to accomplish certain tasks. Those tasks, of course, are hopefully going to be solving problems that you've identified. In our day-to-day lives, we certainly have problems that we need to overcome to do that, we need to understand the problem in detail, devise a plan to solve the problem, carry out that plan, and then review the results of that plan to see if the plan solved the problem that we identified in step 1. Likewise, as we develop code, now the text uses a system called Program Development Cycle, or PDC, which contains 4 steps. Now, depending on the textbook, several textbooks have different methods and different steps in accomplishing this task, but it's effectively all the same process and the same end result. Analyzing the problem, designing a program to solve the problem, code the problem, and test the program. So the first step of analyzing the problem is very, very critical. You need to, when it says analyze the problem, you need to understand every detail of the problem. And I can tell you, in the real world, when you're sitting down to as a team, it's usually you have a team of folks that's going to be developing software. You need to make sure that everyone understands every aspect of that problem. So when you start designing the program, you know exactly every element that needs to be attacked. So step 2 is design a program to solve that problem identified in step 1, and that's pretty much what we're doing throughout the duration of this course, is writing that pseudocode that will later be used to convert over to C++ or Java. And then step 3, of course, is to code the program, and that's using the higher level language to do so. And then when you run that program, you test the program to make sure that you do have the desired results, and it solves the problem that was originally identified in step 1. So during the duration of this course, we're going to be talking about a lot of different concepts. The basic programming concepts are listed here on this slide. You have input, which is values coming into your program; constants, which are variables that you've defined within your code that will not be changing. It will remain the same for the duration of the program. Like, for instance, if you set a value for pi, it will always be 3.14 blah 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 blah, whatever the accuracy that you need for that program. And then variables, of course, have varying values. And processing will take those values and manipulate the data and the values in those variables or the constants. So that will either manipulate and change the variables that you have coming into that program, or create new variables and new values and create new memory locations for those variables, or you can have it go directly to output, which is the next concept. And then output could be your display monitor or a printer or a database. The text also talks about data types, and this is very, very important to understand. Many programming languages, for instance PowerShell, you don't necessarily have to declare your variables before you use them. However, for the duration of this course, every variable that we use in our pseudocode, we have to declare it somewhere in the code before it's used, and we'll get into the difference between global variables and local variables and so on and so forth. But every variable is going to have a specific data type. For instance, it's going to be a string or a character or an integer or a float, and we'll talk about that a little later. But it's important to understand that once that variable is declared for that data type, it remains that data type for the duration. It's also important to understand that if you are going to be using those variables in certain functions later on, like for instance, if you need those variables to do mathematic type functions, they have to be an integer or a float. You can't use a string in a mathematic function. So just keep that in mind as we progress toward those concepts later on. So the text talks about developing a program that is a music purchase program that will calculate the amount of money being spent per downloaded song to ensure that you don't break your budget. So let's take a look at a couple of ways of doing that, and we'll try and get these concepts rolling. All right, so the text has a couple of ways of solving this problem, or at least moving in that direction. It has a couple of ways of writing this code to calculate how much the collection of songs are going to cost you. So this first program that they have on, by the way, this is examples 1.1 and 1.2 on page 29 and 30. So if you get your book and take a look at that, and this explains exactly, there are lines beneath that code that tell you exactly what the code is doing, and you can also compare how those tasks are achieved in the different programming languages. So this is the Java code directly from the book, and then this is the C++ code, and you can see this a little different from how this is accomplished than the Java code. And this is the pseudocode that might be used to do the same thing. So again, we declare those variables, the songs variable and then the dollar price variable, and you'll notice that I have the songs declared as an integer because we're just counting the number of songs, and then declare price as a float, which is going to be the total price of the songs collectively. So we send a message out to the user saying enter the number of songs you wish to purchase. Now this is going to be very, very important through the duration of the course. As you're writing your code, you need to make sure that you try to see this code from the user's perspective. So now we unfortunately don't have a compiler or interpreter that's going to allow us to run this code. So we just kind of need to visualize how this is going to work. So if we didn't have this line that instructs the user what to do, it would come to this line for input songs, and it would just hang there because it's waiting on the user to enter a number, an integer number, for the number of songs they're going to purchase. So of course it would display this line first, enter the number of songs, and then wait for the input, and the user would input that value. And then the next line would set the variable that we declared up top, dollar price equals 99 cents times the number of songs, and then write the total price out, and it will show you the total amount of money that you're going to be spending on the songs. Okay, so back to the variables. So this concept is sometimes a little difficult for people to understand, and especially those that never had any kind of programming experience. So effectively, a variable is nothing more than a label for a memory location. It's basically an address for that memory location, or more precisely, a label for that address. So, and again, when those variables are declared in our declare statement that we saw a little earlier, is declared for a specific data type, and only that data type can go into that memory location. And now the names that we use, and again, this is going to be very, very important later on, and especially as you move into the higher level languages like C++ and Java, because those programs can get very, very lengthy, and it's easy to forget if you use a variable like A, B, or C, or X, Y, or Z, what those variables were originally intended for. So for the duration of this course, all variable names should have a specific meaning, and it should identify what that variable is going to be used for. So I don't want to see anyone using, and even if it's for a variable that's going to be used to count its way through a loop. Don't use C for count. Use use the name count or whatever. Just something that's meaningful to the program, so you don't forget, and so I know what's going on. All right, so as the program progresses, it's going to be doing a number of things. So one thing that we can help let us understand, or let us keep track of the values that are changing, is to make sure that those variables again have specific meaning. So let's take a look at the arithmetic operators on page 37 real quick. So this is going to be pretty important. This at the top of the page, this gives you the arithmetic operators that we're going to be using: plus sign, minus sign. Of course, the asterisk is the function for multiplication. Okay, and that page also gives you the hierarchy of operations, and it tells you, and this is for more complex programs that have a lot of mathematic operations that are taking place in a single line, for instance. It tells you what is happening where. So that's going to be very important to understand, and you may need to enclose some of that stuff in parentheses so it's doing exactly what you want it to do. So data output is effectively the results of your program moving to the intended destination, and what that means is it either displays it on the screen or again to the printer. And in a lot of cases, it takes information from a digital source like a database or a spreadsheet and puts that in another digital source like another database or a different location in the same database. Now, what's very important is to annotate your output as it's being displayed. For instance, if you have if you look on page 40, it explains that, and again, it's important to write your code and to understand the perspective of the user and to understand what the user is going to be seeing. So when you display your output, make sure that you have some kind of information with your output that explains what the output means. So, and again, this week this is just an introduction to the concepts that we're going to be using this term. Of course, the high-level programming languages, and we'll discuss that in the discussion sessions. And use your variables properly. Make sure that you have them given a very meaningful name. Don't use A, B, or C. And understand the program development cycle, and make sure that we are using that for every program that we develop for the duration of the course. And then, of course, the data output again can go to a number of locations: the screen or a database or the printer, what have you. So that's about it for this week. If you guys have any questions, I'm sure that I might have missed something on the material, the reading material this week. So if you guys have any questions or any confusion so far, let me know. There's an area in the discussion to post those questions inside the week 1 itself. So let me know, and I appreciate it. You guys have a good week. Take care.